Hello, everyone. In this video, I will be going over the cross-lagged actor-partner interdependence model. So if you're watching, you probably know something about the APIM, and so this is just going to be a special case of a longitudinal APIM in which we are only going to measure um, kind of one variable across two partners, two people, two dyad members over time. And so the traditional actor-partner interdependence model is really looking at, how does my levels of depression predict how happy I am in my relationship, and to what extent does that impact how happy my partner is, and how the levels of my partner's depression, how does that affect her outcome, and how does that impact my views of how happy I am in the relationship, right? So you're used to probably two variables to measured by both dyad members, a predictor and an outcome. But in the cross-lagged APIM, we are going to measure a single variable over a period of time. And so in this example, I'm going to be going over 4 waves of data from PAIRFAM, which is a national sample from Germany. They have a very large sample. They have lots of dyadic data, and so it's a great data set to play around with and try on new analytical techniques. Or they're great for demonstrations such as this one. And so we are going to be using 4 waves of data. In order to do the cross-lagged APIM, you really only need 2 waves of data. And I've actually published some articles only using 2 waves of data. But the more and more waves you have, the more and more we can begin to look at things like Granger causality. If those of you who are familiar with that is when you have longitudinal data and you see the same pattern effects over and over and over again. And that can help establish directionality across, 2 or 3 or 4 or 5 or 6 different ways. And so what that looks like kind of more specifically is, let's say we have some significant partner effects. And then we have some significant actor effects, but we find that the actor effects are much stronger than the partner effects. Well, in Granger causality, if we have 6 waves, 6 repeated measures in between wave 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, all of those are stronger, then we are beginning to establish that those effects are consistently stronger compared to partner effects. The partner effects still might be significant, but it's really going to be that within-person process, right? So Granger causality is talked a lot about in traditional panel models, but I'm kind of entering that into the dyadic space. And again, this is a 30-second overview of Granger causality, and it is in no way a comprehensive understanding of what it is. It's just kind of a talking point to introduce kind of another statistical concept that you all should probably be familiar with in longitudinal data. So shifting over to our model, we are going to be assessing marital support across males and females. So we have males up here, we have females down here, and I just arbitrarily picked 4 waves of data. All right, so if you've done some longitudinal analysis, you know that 2 waves of data is kind of good, but it's still, you got some repeated measures, but there's still things that you can't really do. And so you generally want 3 waves of data, because that's when you can begin to do some fancier stuff, growth curve modeling and things of that nature. And then when you get to 4 waves of data, that's when you can do some even fancier stuff where you're doing nonlinear growth curve analysis, or you can do with in-person processes within growth curve, such as the growth curve with structural residuals. And so we're just going to use 4 waves of data here for this video, and then there will be a piggyback video where I combine this method with the random intercept cross-lagged panel model to look at within dyad effects, but that'll be in a separate video. So 4 waves of data, measuring, again, the same concept, marital support. So male reports are how supportive do they perceive their female spouse to be, and the female scores are about how supportive they perceive their male spouse to be. Right, so that's specified here. In the analysis command, we don't need that here. It won't harm our model based on the model that we're presenting, but it will be important in a future model that I had just mentioned when we are looking at the random intercept cross-lagged actor-partner interdependence model. We will want this in there. But that can be taken out. And essentially what that does is Mplus by default will correlate all of your X variables. So everything that is exogenous will automatically get a residual covariance, and this is suppressing that default. We are overriding, telling Mplus, do not correlate all of the X variables. All right, so moving into the model, one of the things that you'll notice is that we have, again, 4 waves of data, and we are only investigating T-1 effects. So what that means is we have time T, so let's say it's wave 5, let's just use the final wave. We are only measuring the effects of support at wave 4, predicting wave 5 from both actor and partner, both members of the dyad. So what that means is that we are assuming that the effects from wave 3 to wave 5 are mediated completely through the effects of wave 4, and that there are no leftover effects from wave 3 predicting wave 5 variants above and beyond what is accounted for by wave 4. All right, so that is a very typical kind of assumption that you'll see, and it's a testable assumption that you'll see in the cross-lag panel model literature. All right, and we'll see even some of that as we kind of go through this model. So down here, we have our covariances. So again, we're using dyadic analyses. And so in the actor-partner interdependence model, we account for non-independence in 2 ways. The first are partner effects, and the second are residual covariances. And so here we have within wave residual covariances, such that female perceptions of marital support are correlated with male perceptions of marital support, right? We wouldn't believe that those are independent of one another. Instead, we are going to say they're going to be profoundly impacted and profoundly correlated with one another, probably at 0.3, 0.4, 0.5, 0.6, something fairly substantial. All right, so let's get to analyzing our data. And so again, you'll see up here I've requested mod indices and residual. That's to identify potential local problems. And then also requested basic standardized statistics, as well as standardized effects that standardize both our X and our Y variable. All right, so just looking to make sure that everything looks about the same. Just again, that's how I use the univariate sample statistics. I scan over everything, and this is generally where I catch a missing data problem, a miscoding, a syntax error, or something to that effect. A lot of that can be captured here, or caught here, I should say. And we scroll down and we notice, oh boy, this is not looking good. So we have 12 degrees of freedom, and we have a just monstrously significant chi-square test. Sometimes you'll see good fit measured by the chi-square divided by the degrees of freedom. And some people have said values below 5. Some people have said values below 3, below 2. Either way, we have blown that out of the water. We're at almost 30. So this is just a terrible fitting model. And RMSEA is just exceptionally high. It's at least 3 times higher than our minimum threshold. Our CFI, our TLI are terrible. This is a completely inadequate model. And even the SRMR is getting into the mix. I find this one not to be very discriminating in determining whether or not it's a good or bad model. But even this one's getting high. So we'll take a look at the parameters and just to get a sense of what we have, because I'll show you a few things that that we can do. Um, Again, none of them are going to fix this disaster of a model, but it's something where if you have a good fitting model that you might want to implement. So what we have here is an actor effect, and these are unstandardized. And so 1 unit increase in male support at wave 4 is associated with a 0.693 unit increase um, uh, predicting variance at wave 5. And then we have a significant partner effect where the female partner, when they report higher levels of support at wave 4, that accounts for significant variance in male reports of support. And again, the interval between these waves is about a year. 1 year later, above and beyond male's own report. So we are finding some actor and partner effects. Excuse me. And so we only see that later on. So again, kind of going back to the kind of the Granger causality idea a little bit, which is again the idea that if we have, you know, 4 or 5, 6, 7, 8, 9, 10 waves of panel data, if there are consistent patterns in association where the actor effects are stronger or the partner effects are stronger, then when we see that, you know, over 5 or 6 different waves, then we can begin to, or some people argue, we can begin to make more causal conclusions about it's really those within person actor effects that's really driving these associations. Yeah, the partner effects are important. Yeah, they're significant, but it's really these within person processes. And so again, we're seeing that fairly stably over time. So the parameter estimates for between males and females, between wave 4 and wave 5 are quite similar. Same thing with the partner effects right there. Those are fairly similar. They might be significantly different, but they're not, they're within the same ballpark for sure. And then we also have male effects between 4 and 5 and male effects between wave 3 and 4. Again, relatively close. They may or may not be statistically significant from different from one another. But again, they're in the same ballpark. All right, and the same thing for women. All right, between wave 2 and wave 3. And then we see earlier on those partner effects disappear. All right, and so generally, I will look at unstandardized effects when looking at the APIM, um, uh, because what happens when you take standardized estimates, you are creating a z-score, and so you are dividing by you're creating a z-score based on the sample, and so if the sample variances are a little bit different, the standard deviations are a little bit different between males and females, then you might get some slightly different results. And here you were just using those raw estimates. There's not really anything wrong with standardized estimates, but I find them to be a little more um, a little more subject to other people within your data set, whereas in here it's all just quite straightforward. All right. So you'll see our standardized estimates, and these are kind of make it a little bit more interpretable. But in this case, because we don't have any covariates, these are going to be about the same. So if you look at this, the effect sizes, 0.69, 104 and 693, 107 and 686. Again, that's probably where you're going to see there might be some variance differences between male and female on these variables, and so that can also be a thing that changes these things just a little bit, right? So that's why you'll see differences, even though there are no covariates and everything should be essentially on the same metric. All right, so there are a couple of things that we can do since we have a terrible fitting model. The first is we can go to mod indices to see what is the model kind of telling us. And it's giving us kind of some pretty ridiculous um, uh, suggestions. It's saying wave 3 should be regressed on wave 4. But we know just from, just common sense that wave 4 can't predict variance at wave 3. That just is not possible because of time, right? So the model is, again, the model's picking up that our models are really quite problematic, and it's just giving us the best statistical solution. Whether or not that's grounded in reality and theory, or is even possible, is inconsequential to Mplus. And so these are not small mod indices. These are huge. The critical value for a mod index to be significant is 3.84. And we've got some that are near 80. And we've got a few that are near 80. And another thing that I look for is if I have like an outlying mod indice that's, let's say there was one that was, let's say this one was 100 and everything else was 8. I'll just get rid of some digits here. Look more like this. Then I would say, okay, we got a big honkin' mod indice. It might just be I forgot to add a parameter, and this tells me there's something. I have a good model, but I just have one little area in my model that might not be performing particularly well, and I'll go check that out. But if I have something like this, and I just have consistently high, consistently significant mod indices, then I'm saying, okay, I just have a really bad model because everything is yelling at me. Now, if all of these were 5 or below, then I would say, even though they're significant, I'd say, yeah, I probably got a model that happens. And when you're using structural equation modeling, those chi-squares are highly, highly sensitive. I'm generally not going to worry about that. There might be a few situations where I might, but for the most part, I'm going to let that go. But when they're values of 50 and 80 and 30 and 40, it's telling you just got a really bad model. So it's giving us the exact same story as those global fit indices. It's also giving us some with statements that are kind of ridiculous. A male support correlated at wave 5 correlated with wave 4. Well, we've already got a regression coefficient there. And so, if we were to add this in, this model probably wouldn't even converge, right? Because we have a covariance between the same two variables, but there's also a regression coefficient. So that can be really problematic for your estimation. And we'll go up into the residual, the local fit, the residual matrix, just to see what it's telling us. And it's probably going to tell us the same story as those omnibus measures of CFI, TLI, and RMSEA. Oh boy, this is just sticking out like a sore thumb. So z-scores, the critical value is 1.96. And so this is 5.5 times that significant critical value. And excuse me, that tells us we got a big problem between marital support at wave 4 and wave 2 for men. That means this association is way overestimated. And we got another one here that's highly problematic. We got another one here that's problematic, and another one here, and another one here, and another one here. And there's some others that aren't terrible, even though they're significant. They're kind of within normal bounds. I can accept that. But we got some big time problems here. And so what we can do is a couple of things. We can choose to revise this model. And so one of the mod indices that I picked up on is that we might want male support at 5 to be predicted by male support at 4 and male support at 3. And we'll do the same thing for women. All right. And so now we are saying that the effects from male perceptions of support at wave 3 are going to uniquely predict male perceptions of support at wave 5 beyond the contribution of male support at wave 4. So there's something that lingers from wave 3 that affects wave 5, but isn't transmitted or mediated through what happens at wave 4. All right. So we'll go ahead and we'll run that. And I full disclosure, I have not run this model. This is something I'm kind of doing on the fly because in the next video, I'm going to go over how I would fix this model. And it's by running a completely different model because this one just has a lot of problems. So I don't know what's going to happen. So we'll find out together. But I'm expecting that this association between marital support at 5 and marital support at 3 and female support at 3 and female support at 5, I'm guessing it might be negative. That's something that I just kind of got a hankering for. I'm not sure, but I'm going to go out and make a bold prediction that that's going to happen. All right. So we lost 2 degrees of freedom since we added 2 parameters that are freely estimated, and our chi-square got cut in half. So there's something really going on between wave 3 and wave 5 that there's something that really needs to be there. We still have terrible modeled fit. CFI is beginning to look okay, but again, nothing to brag about. So I would not, in this type of model especially, I would not be bragging about a CFI of 0.94. And SRMR, again, it went down quite a bit, but still kind of RMSEA, just nope. TLI, it tends to be way more persnickety than CFI in my experience. It's not saying things are good, and the chi-square is still really bad. We're at above 15, almost at 16 chi-square per degree of freedom in terms of misfit, and that's no good. All right. So it looks like I was wrong. What made me say it might be a negative is that those associations were overestimated. So I thought there might be some suppression here, but I was incorrect, and that's why you don't guess. Here, what we're finding is something actually really compelling. And it looks like, and maybe we can even try this, that the effects of marital support at wave 5, I'm going to go out on another limb and make some more bold predictions, are going to be equally indicated by wave 3 and wave 4. And even if those are statistically different, just by eyeballing them and looking at them, something doesn't feel right. Something just, that there's this huge effect from wave 3 to wave 5 that is almost as strong as wave 4. So there's a lot of inertia. That's something that you'll hear from wave 3 to wave 5. There's a lot of holdover. There's a really strong autoregressive effect. And the same thing is happening down here. All right. And you'll still see the partner effects are still significant, but their effect size has actually gone down a little bit because I think we're decomposing that really big effect of 0.69 into 2 smaller effects of 0.42 and 0.38. And that's also affected the amount of influence partners have on one another. All right. And so we can scroll down. We'll just go back to mod indices to see what else is there. And we still just got, my God, some really horrible, horrible fitting model. And the model is telling us to do more of that. Our model is telling us that wave 4 should be predicted by wave 2. So this is the exact same scenario that we just kind of addressed with the association between wave 3 and wave 5. The model is telling us that's also happening between wave 2 and wave 4. So we'll oblige. Why not? We'll add wave 2 to both of these. All right. And we'll go ahead and run it again. And my guess is we'll probably actually have a decent fitting model here, would be my guess. It might even be good enough. All right, so we're now within the realm of, okay, maybe we have something. This still is not good, even by how sensitive the chi-square is. We still just have very few degrees of freedom. Our chi-square is still quite significant. Our CFI and our TLI are behaving quite well. Our CFI is brilliant. Our TLI is actually quite good. Our RMSEA, it's still not great. You can still see that there's a pretty wide, I would say there's a moderately wide confidence interval around that. I'd ultimately want this to be a little bit smaller. I'd probably want it to be closer to like 0.77 or something like that to, have a lot of confidence in it, but it's not terrible. And the RMSEA tends to just perform quite poorly in the fewer degrees of freedom that you have. And we have a smaller degree of freedom model right here. So I'm not gonna complain about the RMSE a whole lot because I just don't trust it a whole lot. All right, SRMR tells us we're good. We can actually go down to mod indices and we'll take a stop off at the residual output. We still got one for sure that's still kind of popping out at me. This one, again, it looks a little bit higher than all the others. And even here, we got another one that's still popping out just a little bit. They're not at 10 and 11 and 12 like they were before, but they're still, one of these things is not like the others type deal where they're quite far out compared to others. So that tells me that there's potentially some problems. And so I'm just going to be looking at, I just want to see how big the difference is. It's not terrible, a correlation of 0.03. We have 0.06 here, 0.07 here. So there's definitely some overestimation happening, but it's not the worst I've ever seen. And it might even be something I can live with, but we'll take a look at, see what else is happening. All right, not surprising, right here and right here. We are still seeing some residual effects from marital support at wave 2 to wave 5. The model is telling us there still needs to be a path there. So we've already done between wave 5 and wave 3, wave 4 and wave 2, but we haven't done between wave 2 and wave 5. And the model's telling us that those need to be there, right? These other ones are nonsense. They can't even be, they're not even possible. So we're going to go ahead and we're going to add those pathways. Why not at this point? All right. So we'll just add those in and we'll see what happens now. My guess is we're going to have a great fitting model. And how could we not with all of these parameters that we're just throwing at it? Yeah, it's beautiful. Non-significant chi-square, CFI, TLI are going to be 1, RMSEA is 0, SRMR, it's doing great. But look at how many parameters are predicting marital support at wave 5. Wave 2, 3, and 4 all have unique prediction and account for unique variance at wave 5. So that to me just doesn't make a whole lot of sense that the effects of wave 2 to wave 5, just going back to path tracing rules, it's operating directly through just operating directly between wave 2 and wave 5. It's also operating indirectly through wave 4. So the effect of this first path, remember we added in a path, wave 4 being predicted by wave 2. So there's an effect there. So wave 2 is also associated with wave 5 through an indirect effect at wave 4. So there's 2 or 3 or 4 different ways that this association is getting to this one, and it's still significant, right? So that tells me there's a big time problem here. And that tells me this analysis and this model is not worth anything, right? It's telling me that there's a lot of problems here. So rather than pretend that this is my original hypothesis and the model I started out with, I'm actually going to move to a completely different analytic framework. What I'm going to do is I'm going to, in the next video, to show you how to conduct the random intercept cross-lagged actor-partner interdependence model. All right, and so what that model will do, and I'll talk more about it in that next video, is it's going to suggest that there is a stable trait-like component that is being smushed together with individual variations around that trait. So think of that trait in the context of the study as attachment, right? So your underlying attachment. So if you're securely attached, then you're probably going to probably view yourself and your partner as more in line with quote unquote reality. You're going to recognize their support. You'll be grateful. You feel comfortable with both intimacy and distance. You feel fine being your own person, but also you love being with your partner. And so that's going to be stable over time. Your attachment, it's subject to change, but over the span of 4 years, for the most part, it's going to be relatively stable. And so we're going to pull that out. We're going to pull that secure trait-like variance out of these effects. And then these will be within person effects, or how an individual deviates from their stable trait-like disposition. You can view it again as as a disposition as well. And so people will vary. We have a general disposition to be securely attached, but let's say we've had a rough month at work. We might be just a little bit less securely attached than we usually are due to work-related stress. So what we're going to do in the random intercept cross-lagged APIM is we're going to partial out that trait-like component from those individual deviations at each of these waves. And so what tells me that model is going to be the best fit to the data is because all of these effects are significant. So there's something lingering from wave 2 predicting wave 5, wave 3 predicting wave 5, wave 4 predicting wave 5. And that tells me there's a something else out there that is potentially confounding these associations. And one argument is that it's a trait-like component that is not being measured here. We have no indication of a trait-like stable effect in this model. So that is what we're going to be testing in the subsequent model. So hopefully this has been helpful and shed light on some statistical concepts around longitudinal data, around dyadic data, and hopefully about not just throwing parameters at a model and hoping and praying that you get a good model and that you just throw parameters to fit a bad model, because really this story that this model is telling is not very good. And so again, hopefully it's been helpful to you all.